HTML5 postMessage offers a simple messaging API that allows us to send messages between origins. So we have the concept of a sending side and a receiving side. And there's essentially two different setups that you will commonly encounter. One would be the receiving side being the parent frame and the sender being a child iframe embedded within the site. And the other option is to have a page open up an external window and then send it messages. So looking at the iframe example to begin with, this is a simple code example which sets up an event listener to receive an inbound message from an embedded iframe. When that message is received, it then displays an alert box containing the message content. So this is the code. These are the pieces of the code that are important here. The initial binding of the event listener. So here on the window object, we're binding an event listener for message events. The receive message function is then used to handle that event. So when we send messages sent via postMessage are referred to as events. Events have a number of different properties. So the most important properties for us here are the origin property and the data property. So in our example, the receive message function takes in the event and it displays an alert box with the event.origin and event.data. So if successful, should say message from and then the origin of the received message, where it originated from, then saying and the content of the message. The child iframe simply has a post message to send a message up to its parent. So here we refer to the parent page as parent.postMessage, and we're sending hi parent, I'm ready. Using a asterisk wildcard, this just means to send to any origin. We can use that to filter to say send to only specific targets. In this case, we're saying send to all. And this is what that would look like. So this example is in the code examples folder, but it's so simple. We'll stick with the slides here. So we have the embedded iframe, and the iframe sends a message to the parent, and we have this pop-up message as a result. In terms of security, certainly from the receiving side, it's really up to the developer to validate the inbound message. So when we bind that message listener, it will receive inbound message events, and it will pass them to the function that we define. That function will then needs to validate, firstly, did it expect to receive that message by checking the origin. So a secure setup would validate that origin to say, do I accept messages from this origin? And this is really, in most cases, this is the source of the vulnerability. The fact that if the developer who put this application together doesn't validate that origin, then the message could have come from a malicious source. Once we've validated that origin, if we are doing this securely, we can then extract the data from the event and then process it. And post-message event listeners are used for all kinds of different things. It may be something benign, like resizing a frame, or something like that, or it could be something more dangerous, like setting the contents of the page and altering the DOM in an insecure way. When we look to attack message listeners, if we find a message listener that doesn't correctly validate the origin, we're not usually going to be part of the embedded iframe. We're not usually, as the attacker, going to be able to control the contents of that iframe. So in our case, most of the time we're going to be using window.open to open up that page with the listener and then send it messages. So this is an example. Here we just open up a separate window to google.com, and we're going to send it a message saying hello Google. So in JavaScript we can use window.open to open up our target page, and then we can use postMessage to send a message to it. So the security of the receiving side is all about validating where the message originated from, and on the actual sending side we also have a security concern. So an example would be, let's say that our application frames a page, and that page then sends us some sensitive information, some information that's specific to that particular user. If that page, the way that postMessage works is we say postMessage and then the message content. We also define the target of the message. Now, one way we can do this is by defining a wildcard. So if we have a page that, if we're currently logged in, let's say we've previously authenticated, we have a session token. When we request that resource, it then embeds a post message into the page that sends a message up to the parent. If that message contains user-sensitive information and we're using a wildcard, that means that the sensitive information will be sent to anybody who can frame that page. So to recap, there are two broad categories of vulnerability here. The first, I guess, is the disclosure of sensitive information. If a page will send a message to its parent and that message is sent to the wildcard target, if that page can be framed, then the attacker could frame the page and then consume that message. We'll be going through a demonstration of this shortly. On the receiving side, if the receiver doesn't validate the origin of the message, then it may, if it then processes that data and does something potentially dangerous with it, we could potentially send a message from a malicious third-party domain, which will then allow us to perform a cross-site scripting attack. To better understand post-message vulnerabilities, we've mocked up a case study, a vulnerable web application that demonstrates two of the most common vulnerabilities that you will find with HTML5 post-message. So this example is based on a real-world application. We've obviously changed the names to protect the parties involved. At some point in the near future, this video has been recorded in May 2015. We have actually uncovered a vulnerability in a lot of high-profile web applications that is very similar to this. And we will be publishing information about that issue once the vendor has patched the flaw. But for now, we'll work with this mock-up, this case study example. So in this case, we have the AppCheckinG shop has acquired a social media arm called Facepalm, and they want to integrate their features into the AppCheckinG shop seamlessly for any existing users of the Facepalm application. So the way this works, the user would first need to be authenticated to Facepalm. This is the UI we saw right at the beginning of the presentation. User logs in, gets a session ID, and remains authenticated to Facepalm. When accessing the AppCheckinG shop, they can click on the Facepalm notifications tab, and they'll receive their Facepalm notifications integrated within the AppCheck shop website. So as before, we're going to register an event listener in the parent page in the AppCheck shop, and as before, we're going to use the same naming conventions. So in this case, again, we registered an event listener for messages, and the function that handles the message is called receive message. On the sending side, so in order to receive messages from Facepalm, the AppCheckinG shop creates a hidden iframe in the page. That when the iframe is loaded, it then sends a message back to the shop containing the Facepalm notifications that should be displayed. So this is the structure of the message. So we have the parent post message call, followed by the message itself, and in this case we have a JSON object. And as you can see, we're sending it to any target origin. So when the message is received from the Facepalm iframe, the UI within the shop is built up from data sent within the message. So the first thing that we see happen, the username field from the message is read from the message, and it's placed within the page using the inner HTML attribute. So as you can see here, welcome Gary is taken from the message, and the word welcome is added to the beginning there. We then iterate over the messages. So here we have a loop reading the message attribute from the data object. So if I flip back, we first read the username, then we iterate over this list of messages, and for each message with and title, we place that within the page, and that's what this loop's doing here. And essentially, and quite critically for this vulnerability, we're using the inner HTML attribute to set that data. And this is what the final thing looks like. And so these are the messages from Facepalm formatted within the AppCheckinG shop. So I'll break out now and show a demo of this. So to begin with, we need to be authenticated to the Facepalm website. So I'll go ahead and I'll log us in again. We can now close that window and access the shop. So if I click on the Facepalm notifications, we can see now that the list of Facepalm messages has been populated in here. And this has come from our hidden iframe, and the message has been sent to the parent page on AppCheckinG and populated this Facepalm notification section. So there are essentially two vulnerabilities in this setup. First of all, the parent page, the AppCheckinG shop, it doesn't validate that the message originated from Facepalm. It will receive messages from anywhere. So the first attack we're going to look at is performing a cross-site scripting attack by sending a message to the vulnerable AppCheckinG website. So if we head back to our, in fact, I'll open up another window to demonstrate this. If we head back to our demonstration HTML files, so in this case, I'm using the URL attacker.nsa.gov to show that we're on a different origin. If I go to my basic exploits, and in this case, we're going to send a message to the vulnerable window. So we're going to exploit the postMessage exploit example 1 message to window. So first thing I need to do, and if you remember earlier on, we said that in most cases, although the application it was designed to use iframes, we can't control that Facepalm iframe. That's hard coded in the application. We can't, get into that situation. We cannot control that iframe. So instead, we're going to use window.open. So if I take my vulnerable page, which is shop.appchecking.com, Facepalm notifications, I'll copy that out, and we'll paste it into the top attribute there. It's top window. And we'll click open to open a window. So by opening this window, this attacker.nsa.gov page can send messages to the shop.appchecking website that we've opened in this external window. I'll just put these into separate windows so we can see what's going on. So if you remember back to the original message, this JSON object was processed, and in this case, it was an Amazon order, which then populated this notification within the page. Since it doesn't validate the origin of the message, we can send a message from attacker.nsa.gov. So I'll just change the Amazon order shipped, which we can see rendered here, to test 1, 2, 3. So if I send this message, we can see that the page has received the message, and using the inner HTML attribute, it's changed this value. So because we're using inner HTML, and there are other methods that do a similar thing, we can embed malicious HTML code via this same method. So to demonstrate this, I will send through an image tag, and the image tag is going to contain an event handler containing JavaScript. So img source equals foo on error equals alert document.cookie. So if successful, as well as the text-based message, we're also going to send in this malicious JavaScript embedded within an image tag. So if I click submit, as we can see, the image tag has been injected, and we have now popped up an alert box containing the user's cookie. So this is a classic example of cross-site scripting, although it's delivered via a non-classic mechanism. So by sending a message containing HTML code, because the site didn't validate the origin of the message, it is parsed our message content, and it's embedded this dangerous attribute into the page, and we've fired up an alert box with the cookie. So a malicious attacker could exploit this. Instead of firing an alert box, they could send in some JavaScript, steal that session ID, and send it off to the attacker. Or in fact, sending a JavaScript to perform what we often term on-site request forgery, and that's basically to place a JavaScript in the page that automates the actions of the user, so carries out whatever tasks on behalf of that user. And in this case, we've got a simple e-commerce example, but perhaps in a more sensitive site, in a banking site or something like that, that JavaScript could cause a lot more damage by carrying out bank transfers and things like that on behalf of the attacked user. So in terms of the second vulnerability that affects this application, we look at the sending side of this equation. So in order to work, the AppCheckinG shop loads up a Facepalm component into an iframe, and that iframe communicates with the parent application. And as we can see in this example here, the use of the asterisk means that this embedded iframe will send this message to any site that frames it. So if we just break out of this for a second and go look at the source code for the AppCheckinG website, if I go and find the iframe, We can see that the way the iframe that's loaded is messages.facepalm.com, and we're loading up the inner iframe. So if I copy this link and I go back to my exploits, in this case we're going to use the receive message from frame exploit, and all we need to do here is paste in the frame that's loaded by the AppCheckinG shop. Because this message will be submitted to anybody that frames it, and because we are logged into Facepalm, simply clicking open will embed this iframe at the bottom of the page there, and the inbound message receives our sensitive, potentially sensitive information back to this parent page. So by design, this was expected in the AppCheckinG shop, but because we use the asterisk as the target for the message, any malicious site is able to frame that page and receive the inbound message. So a common programming pattern that we've encountered in a lot of high-profile websites out there on the internet is, rather than using an asterisk to say, send this message to any target location, the origin of the target for the message will often be supplied in a query string parameter. Now, generally speaking, the reason why people do this is to allow a particular post message component to be used across a wide variety of different sites. So, if, for example, if I'm Google, I may want to create an iframe component that can be framed by YouTube, by Gmail, by Google.com. And in order to instruct the inner iframe where to send the message, I pass an origin query string parameter, which is then copied into the post message function call to direct the message to the correct origin. Now, in many cases, or at least in some cases, this value is validated at the server. So when this request is received, the origin parameter is checked. The domain is then validated to say, is this domain, is this origin in a list of trusted origins? And if it is, I'll send a message. And if it isn't, then we'll just deny the request. We won't issue that post message call. Now, as we'll see in a short while, even when this is validated, there are still some issues that can occur, and we'll give you some examples of what those might be. So just to show you what AppCheckinG, the web application security scanner, how that can help you identify these flaws. So we have a built-in browser engine that renders each page that we access as part of the scanning process. And through a combination of static and runtime analysis, we trace any post message calls that occur as we're accessing the application. So one of the things that will always happen is we will log any JavaScript handler that we see processing messages, and we'll also give you a list of the messages that we observed during the initial crawl to say these messages were sent to this given handler. So this first example is useful when we try to track down future vulnerabilities. Once we've scanned the application, we can come back to this and we can see, we can take a look at the handlers, determine if they are acting securely or otherwise, and then investigate those further. We will also pick up common post-message vulnerabilities. So in this example, we scanned our mock-up case study application, and AppCheckinG has flagged that there's a JavaScript handler that is not checking the origin. So we report this as post-message origin not validated, and this is where we're processing messages, but the message origin has not been checked within the handler itself. So in terms of defending against post-message flaws, first and foremost, in the receiving side of things, if by design you're able to do this, it's always good to check the origin to ensure that it came from a trusted source. On the sending side, it's important to ensure that if we're submitting sensitive information, that within that post-message call, we're defining a trusted target origin. It's to prevent the browser from leaking sensitive information to the attacker. In some cases, anonymous messaging is by design, and it's very much expected behavior. We'll see this with things like Facebook, YouTube. When we're integrating components, they may be anonymous messaging going on because they don't want to maintain a full list of potential origins. Anonymous messaging is perfectly acceptable in those cases. The key thing in this example, though, is we need to make sure that when we do process the data, that we don't do anything unsafe with it. And this is very much in line with DOM-based cross-site scripting. So essentially what we're saying is if you're going to process anonymous messages, ensure that the data is not used in an unsafe way. So examples of that will be using document write. So document write would write the information from the message verbatim into the DOM and would allow cross-site scripting to occur. Any attributes that set the specific HTML, so inner HTML and outer HTML, they're inherently dangerous. That will just replace the HTML content of whatever attribute this is attached to, whatever component this is attached to, and again can be used to perform a cross-site scripting attack. Any attribute that is used to access a URL, location.href, if we're creating an iframe or something and we're setting a source attribute, anything that directs a browser to a URL is potentially exploitable. We can use JavaScript protocol handlers, so the JavaScript : JavaScript can be used to exploit that scenario. And again, passing them directly into a jQuery selector, it can also be dangerous. So yeah, if the messages are anonymous, ensure that anything that you're doing with that data is completely benign and can't be used to inject HTML, JavaScript code into the page. So in terms of validation, so in the case where there is a origin being supplied within the query string, in order to configure where a post message is sent, it's important that we do that validation correctly. So what we can often find is when there are a range of domains that are required. So let's carry on with the Google example. If Google wanted to validate that they wanted to accept an origin in the query string, but they only wanted that origin to fall within a certain range, we often see regular expressions used. So this is a very simplified example of a real-world vulnerability that we encountered. So in this case, this regular expression is designed to check that the supplied value is HTTP or HTTPS and has a host name mail.google.com, and the $sign there to indicate that should be the end of this particular data. So on the surface, to the naked eye, initially this looks quite okay. And it's a common mistake that's often made when using regular expressions. So the problem here is the dot character in a regular expression means any character. So in this case, the regular expression is flawed in that any of these values will pass validation. So as an attacker, if I encounter something like this, I can go ahead to a domain registration website, register mail.google.com, and that will pass validation and allow me to attack this application. So as an example, for £6.99, you can register mail.google.com, which would pass validation using this regular expression. We also see other validation flaws. A common trick or a common pattern for validation is to use the index of attribute, the index of call, to say, does this string occur within the tested value? So here we're saying, does using index of, does HTTPS mail.google.com exist within this value? We see this all over the place for different validation routines. If we used it in the origin check, we could simply use a subdomain of our attacker's domain, and again, we'll pass validation. So the fact that our origin begins with that tested value means that we'll pass validation.